Welcome to Math 25, the first Monday. So we're starting week 2. And for health decisions, it starts with patterns, but this is again designed as the icebreaker work in groups meet your classmates activity. And I want to find out which day of the week has the best attendance, and then we'll go back and do this. So we're starting at calories again. We did this a little bit on Friday. We're going to do more. I'm gonna close that. Okay. So we talked about calories, their energy, you burn more when you exercise. And there was this nice formula where you just multiply 3 things together. You multiply someone's weight, you multiply how many minutes they exercise. And we had a couple of problems trying to trick you, giving you time in hours instead of minutes, and you would have to multiply by 60. And then there's a scale factor you multiply by. And we talked last time about how the scale factors are all just kind of estimates. They're baloney. It's not true that everyone weightlifts the same way. If you're very aerobic about it, the number would be much higher. If you're very mellow and talking to your friends the whole time, the number would be lower, and so on for any of these. No 2 people will swim or play basketball or do ballroom dancing or any of them with the same intensity. But we're in a math class, so we need some numbers. So this is our official chart, and we just pretend it's accurate. We did these 2 problems last time. By the way, if you want to see that, then go to the syllabus and go down to the meeting archives. And then you can see, here's the Jamboard for what we wrote last time. Or if you wanted to go to the videos, they're in Zoom and YouTube. The advantage of Zoom is that it gives you a transcript on the side of all of our talking, and it's searchable. So if you want to search for when we did a certain thing, you can jump right to that part of the video. YouTube doesn't have that feature, but people are more used to YouTube. If I'm wasting my time doing both, let me know, and I'll stop uploading it to both. Okay, back to our lecture. So we've done the first 2. Let's just make up one. So I'm going to grab the formula. Make it bigger on my screen for myself. Okay. And I'm going to grab our chart. Oops. Okay, so just call things out. How much should our person weigh? You're muted if you're talking.
Let's say 150 pounds.
Oops, or did my thing? Nope, I'm still listening to the headphones. Am I not hearing you when you're talking? Is my audio having problems? Someone pick a weight. How much does our pretend person weigh?
150 pounds.
Uh, 150 pounds.
150. Oh, okay.
I don't, maybe your mic isn't working. I'm not sure.
So, and what kind of exercise are they doing and how long?
They're running for 30 minutes.
I couldn't hear with the mic your choice. What was the thing they're doing?
Running.
Is my headphones might be cutting out. Let me turn them off and on. I'm sorry.
Can you hear me now?
Okay, try again. Let's see. Okay, can you tell me again, Ross, what exercise?
Running.
No, I'm still not hearing. Okay. I'm sorry, I'll take those off. Can somebody say something, I'll test these speakers.
Um,
There we go.
Running.
Running, okay. And running gives us the scale factor of 0.9, 0.09. So we'll plug it all in. Calories is the 150 times the 30 times the 0.09. At 405 calories. Okay, everyone happy with the simple example? The ones we did last time involved a slightly more complicated thing. Let me make that bigger for us. So people did two things. He ran for an hour and then he did half an hour of weightlifting. So let's look at that one. Let's change the weight though, so it's not exactly the same problem as what we did before. So instead of 150, let's have him weigh about 180. So this one was trying to be tricky. We have runs for an hour, and we also have the half hour of weightlifting. So it's a two-part problem. We're just going to say at the end, we add them all up. The runs for an hour, we multiply those three things together, his weight, an hour would be 60 minutes, and running was 0.09. The weightlifting, he hasn't changed any weight. It's half an hour, so only 30 minutes. And the weightlifting is 0.039. Can they move? No, I can't move that. Okay. So the first part, 180 times 60 times 0.09, that was 972. And the second part, 180 times 30 times 0.039 is about 211. get 1,183. Okay, questions with that one? Wave or thumbs up or something if you're good. Okay,
Actually, I had one question
sure.
about that. Why did the why did the calories change for the weightlifting?
Why did the calories change? Why did I round them here?
Yeah.
Because we don't normally talk about tenths of a calorie. None of these numbers are very accurate. We probably don't even know his weight to a tenth of a pound. Scales just usually aren't that good. And we talked already about how the numbers in the chart are all kind of bogus. You and I would weightlift very differently, even if we're doing the same exercises. So since all of this is a little bit hokey, then it doesn't make sense to try and say we know to a decimal number how many calories he burned.
Okay.
So that would just be exaggerating how well we knew things. You could even round this to something like 1,200 as your overall answer and be able to defend your answer that that's really about all we know, is kind of like that ballpark. But we'll pretend that we can do it to the nearest calorie. That's just how people talk about this kind of thing. Okay. Again, there's the wiggly about equal sign. That means I just rounded in that step. Okay, Odette weighs twice as much as her daughter. If they both do the same exercise, will she always burn twice as many calories? I'm guessing that's still kind of small. Go back to our formula. If their minutes are the same, and they're doing the same sort of exercise, so that's the same, and we're taking the weight and doubling it, is that always going to double the answer? Make a guess, yes or no?
Yes, I think so.
You think so? If we put in some numbers, so this is like 4 times 5 is 20, and we have something times 20, and then we have twice as big times 20, it's going to be twice as big. It might be easier to see this if you put in placeholders. But yeah, if we put in something and then we put in something twice as big, the answer is going to be twice as big. Okay, as a side note, if you want to lose weight, you're trying to burn fat calories. The practical lesson is don't worry about this math, just exercise a lot. But we're a math class, so we'll be picky here. When you do more intense exercise, then your body needs more short-term energy. So you tend to burn a smaller amount of fat because you need the energy from carbs to get your quick energy. So as a really complicated problem, let's show that even if you're doing more intense exercise, you will still get ahead on burning fat just because you burn so much more calories total. So two-part problem. On one hand, you have somebody that's going to be a walker. So they're going to have 150 pounds, 30 minutes, and the number for walking is 0.037. So we multiply these three together. And we get about 167 calories. I'm rounding again for that same reason. Now we just read in a sort of skipped way that when walking, about 3/4 will be fat and 1/4 will be carb. So let's divide the 167 . And say that 3/4 of it is about 126. And 1/4 of it is about 42. Come on, zoom, there we go. Anyone want me to go back and review how to get 3/4 of a number or 1/4 of a number? Yeah, okay. The easiest way to do this is to say, well, 3/4 and 1/4 is about this, or is equal to 0.75 and 0.25. And then is becomes multiply. Let me write that better. Is that enough ringing a bell, or do you want me to talk more? That's good. Okay. And I'm rounding a bit, right? These two don't add up to 167. I'm off by one. Well, there we go. That's about how much we want. So the 3/4 was the fat, and the 42 was the carbs. Now we'll do the same thing with someone who's running. They still weigh 150. They still are doing half an hour. Now we'll do running, which is 0.09. And we get 405. That was our made up example problem from earlier, wasn't it? Now with that, we're going to break it up 50-50. When you're running, it's about half and half. So times 0.5 or divided by 2 if you like. And we're getting about 203 on both sides. So we can see that even though a bigger percentage, 3/4, was fat when you walk, you wind up burning more fat calories by running just because you burn so many more calories. And if you can do all of that, that's about as complicated as I can possibly make these. Any questions on that big 2-part problem? No? Okay. Thank you again for having your video on so I can see when you nod your head and stuff. Okay, can we actually check this exercise formula? We can't measure directly how many calories we burn. We can do an estimate and see if our breathing rate or our heart rate goes up. And when we do more intense exercise, it's proportional. If we double how intense we are exercising, we'll double our heart rate or double our breath rate. This is a great thing to do if we are all in the same room together, make little project teams and do this. But for now, we'll just have you read about what happened in past years and not actually try and do this on Zoom because you can't get together. Okay, part 2 of calories is calories in food. Whatever you eat will either be carbohydrates, proteins, or fats. That's just everything else our body doesn't digest and we don't care about it, it'll go right through us. So carbs and proteins have 4 calories per gram and fats have 9 calories per gram. It's kind of interesting that so much of our country is resisting the metric system, but we have grams for food all the time. So that's the normal measurement we use instead of ounces for this kind of problem. So if there is a food label, you've all seen things like this. Here's a bagel. Arthur's in a rush. He wants to eat his bagel. How many of the bagel's calories are from carbohydrates or proteins or sugar? Let's look at that. Okay, more on my food label while I find the answers. So for carbs, where should I look? Is it just too small on your screen? Which is the carb number?
47 grams.
47 grams right there.
So I didn't really know what you were asking at first.
Okay, there we go. So carbs have 4 calories per gram. So we'll take that, multiply it by 4. And get 188. Proteins, right there, 9. And it's again times 4. Then fats is a little funny. We have on one hand, total fat is 1 gram. So we would expect that we could multiply by 9 and get 9 calories. On the other hand, it tells us up at the top, calories from fat is 13. If I add these all up, I get something a little funky. So why aren't my numbers coming out nice? How come the 233 is bigger than the total calories of the bagel? How come our multiply by 9, which should work, doesn't give us the right answer?
Do you need to add the saturated fat, the 0.2?
No, that's a part of the total fat. So
Oh,
that's a good guess, but that's not it.
mm.
If 13 is the right answer, what should we change the 1 to be instead? It has to be a little bit bigger than 1 if this number times 9 will be 13 instead of 9. If we do 13 divided by 9, we get about 1.4. So if it's 1.4 times 9, we'd get the 13. So in other words, these are rounded. Whoever writes the labels isn't caring about decimal amounts. They're just going to take these numbers and round them. So that makes our math have slightly different answers because you can't round in the beginning without breaking things. So once again, calorie math, it's good for some basic information, but don't trust this is the most accurate thing ever. Okay, it also asked us from sugar. So sugar is a kind of carb. So there's 5 grams of sugar. We're going to multiply it by the 4 because it's a carb. So the sugar grams are part of the carb grams. That 20 grams of sugar is part of that 188 already. It's just one of the many kinds of carbohydrates. Okay, back to our lecture. We already did 17. This was the, how come it says 13 calories from fat? Because the number 1 was actually probably 1.4, and they just rounded it, so it looks like it has less fat. Here's another one. Okay, let's have milk with our bagel. So a cup of milk has 5 grams of fat. Twelve grams of carbs. All of those are sugar. And 9 grams of protein. So let's change this gram amount into calories amount for all 3. So for fat, what do we multiply by?
9.
9. And for the carbs and the protein, those are the 4s. Oops, I'm writing the wrong thing looking ahead. Sorry, bad lecture. Okay. Everyone happy with that? Yeah, okay. Thank you for nodding or thumbs up or whatever. Makes it much easier. Okay, 18, we could do the same thing. We have an imaginary chocolate frosted sugar bombs. They have so many grams of fat and carbohydrates and protein. Let's do one more because we have time. Okay, you try it first. I'll fill in the answers after a little pause. Okay, as before, the fat is times 9, the others are times 4. I should probably be consistent and round that to 12, huh? Since I've been rounding calories all day. I'm writing in yellow to remind us that the sugar calories are included in the carbohydrate one. If someone asked, what's the total number of calories in our serving of cereal, I would add up the 12, the 88, so that's 100, and the 10. I wouldn't add the 36 because that's already in the 88. I don't want to double count it. Okay. Almost done with this section. The USDA has some recommendations. If you are on a 2,000 calorie per day diet, what should you be eating? So many grams of carbs, protein, and fat. And someone has already multiplied by 4 or 9 to make these have calories also. Then there's a note about dietary fiber and added sugars and saturated fats, if you're actually caring about that. We had a formula from Math 20 that if you want to know the percent of a whole, you would do the part divided by the whole. That gives you a decimal, and then you scoot the decimal point to make it into a percent. So we'll use both of those and do a problem that's finally a bit more interesting. So Odette's on a 2,000 calorie per day diet. She eats 2 eggs and 2 slices of toast for breakfast. And that food has 13 grams of fat. What percentage of her recommended fat for the day has she eaten? So first we go back up to here and say that if she's on this 2,000 calorie a day diet, she can eat 65 grams. So 13 grams is the part she's eaten, and 65 grams is the whole amount she gets. Then we had, how do you find a percentage? Part divided by whole. And we get 0.2. And then we like to talk about these sorts of things with percentages. So the acronym RIPLOP, wife next to me is trying not to laugh, reminds us that we're always going to scoot twice to go between percents and decimals. We want to go in to percent format. So we're going to go right to go into percent format. So she's eaten 20% of her fat for the day with her breakfast. If someone eats a little more, they have bigger numbers. And there we go. Okay, now I'm going to talk about the 10 problems and make this a little bit better fitting at the screen. That's still readable? Okay, so when we finish a section like this, then there are 10 exercises for each section. They don't have answers. And one thing you can do is use this as homework. Try them by yourself if you have to. It's better to work on them with groups. And I'm going to send out an email after class, like always. And one thing I ask today is if you mind me sharing your email with the rest of the class. Any MyLane email is public by default, but some people have shared a personal email, and I don't want to share those without your permission. So to help you form study groups and work together, then we'll share emails. We'll also have the half hour before each class is a good time to do these things. That's what the study groups are for. So here's 10 problems. You work on them. They look very similar to what we just did. And write them out on scratch paper. When you're done, when you have nice answers in front of you on paper, then you click the link to go to the form. Don't click the link until you're ready. Otherwise, you'll be too tempted to try and do funky things because you have multiple choice. This form lets you just pick answers. I'm just going to pick a few to make the form happy. And then at the bottom, it says process my answers. So you click on the button and it sends you this bizarre code. Your job is to highlight the code and copy and paste it into an email or a text, send it to me, and then I'll tell you how well you did. If you're working with a group, which again I recommend, tell me who else is in your group so they can all get credit for turning this in. So this will be due 2 days, 2 class days after we don't have questions on it. So I assume that when I see you tomorrow, there will be questions on these 10 exercises. So it won't be due yet. We don't know when it's due. Maybe Friday, there won't be any questions on these finally. And then we can say, 2 class days after Friday will be next week's Wednesday. That's when it's due. Maybe we'll still have questions on this even into next week. So that's how that kind of homework works. If you want more practice, then the random exercises give you answer key, and you can just keep practicing as much as you want. Every time you load the page, the numbers change, but the answer key has the correct answers for those numbers. So you can just keep reloading the page and do as many random exercises as you want. And the random exercises are the ones that will be on your tests later on this term. So if you're good at those, you're all set for the tests. Nothing new is going to jump out at you. When we go to the main table of contents thing, then you can see direct links to that. We had the 2 sections about calories. You could go right to the 10 exercises. You could go right to the random exercises. In your syllabus, when we're looking at the achievements for grading, then a bunch of them have these Math 25 stars. So if you or a group you're in turn in the 10 exercises for calories, you'll get a green check mark here and we'll know it's done. You don't have to do all of these. To pass the class with a C, you need to do a little more than half of your homework. But it's an easy way to get lots of stars because homework is pretty straightforward. The stars with the Math 20, ignore those. That's for the Math 20 class. And again, at the very end, it says if you have 4 late homeworks, then you'll get a minus because you're sort of falling behind. But it's not too hard to turn in some code before they're due because we have so many days we ask questions about them. Okay, any questions about homework, how it works? So let's have you go back to those 10 questions. We have 5 minutes. Why don't you, who are still here, see if you can get done a few of these. I'll turn off the recording and you can ask me any questions you want.